Hello students, welcome to my classroom. In this video, we are going to talk about the concept of arithmetic series. All right, so in order to first begin the concept, I will give you a little definition of two fancy math words here. And the two math words are sequences and series. Basically, what happens is that at the end of every question, they will use these words. And it does kind of get confusing if you don't know the difference between the words. So whenever they use the word sequence, they will be putting a comma in between the numbers. So let us say we have a sequence going on here, 3, 8, 13, 18. So as I'm writing it, you will understand that every time I'm adding 5 to every previous number to get the next number. So I added 5. And anytime they're talking about the word sequence, they will put a comma between the numbers. Whereas when they talk about series, they will add a plus sign in the middle. So it'll be 3 plus 8 plus 13 plus 18, or they may be asking you a question about sum of this series. So they won't use the word sequence then. So series indicates sum. That's the important meaning of it. And sequences indicates a list of numbers. All right, with that taken care of, we will start understanding the definition of arithmetic sequence. Let me let this fly away. And we will start with the definition of arithmetic sequence. So I hope you are writing this with me. Yeah, Braden. So arithmetic sequence is a sequence in which there is a common difference and usually they label it as D, the letter D. And the common difference, D, is between consecutive terms. So hopefully you're able to read this over here, and now I'm going to explain this with an example. I'll change color. So for example, our sequence here is -3, -1, 1, 3, 5, 7, 9. So I'm trying to look over here whether it's arithmetic or not, and if yes, then what is the common difference? Now, let us see if the common difference, that means it has to be the same number that you're adding or subtracting to the previous term to get the next term. So negative numbers get confusing at times. I will take the positive numbers and I will see, okay, 3 plus what is 5? Plus 2. 5 plus what is 7? Plus 2 again. 7 plus what is 9? 2 again. So I can check that between other numbers also and see that every time we have the same number 2 being added. I do not change the number ever. So that number is called the common difference. And it can be the minus sign, negative numbers also, it's the same thing. Such sequences are called arithmetic sequences. So D equals plus 2. And the terms are given as follows. So anytime they ask you, okay, well, what is the next term? So I'll just add 2 to it and I'll get my next term, which is 11. So is this an arithmetic sequence? Yes, it is. All right, let's do another example, students. -8, 6, -4, 2, 0. Now this is your sequence, and I'll let you take 10 seconds of thinking time and think about whether it is an arithmetic sequence or not. That means what you need to think is, do you have every time, do you have the same number that you're either adding or subtracting from the previous number to get the next number? So take your time and think about the answer. All right, so when we looked at these numbers, I saw that 2 to 0, I'm maybe subtracting 2 here on this one. On this one, -4, I'm getting a 2 here from -4. So what am I doing? Think about it. On the number line, I have -4, and I'm jumping to a 0, so I've jumped 4 steps, and then I'm adding another 2, so I'm adding 6. So just by looking at this, I'm seeing that these two numbers are different. So I can say that no, it is not an arithmetic sequence. All right, so I hope that made some sense. There's too much going on this page, so I'll let you look at it fly away in front of you. All these notes are gone. Next up, we will find the general form or a formula to find the nth term. All right, so let us say our first term will always be a1. Now, there is a little 1 that they write at the bottom of the number. So that tells us the first term. In the same way, we'll have second term is given as a2. Third term is given as a3. Remember, the little number is at the bottom floor of it. Fourth term is a4. And so on and so forth. So let us say we have our sequence as 1, 3, 5, 7. And in this sequence, I'm adding a number 2 every time. I again added a number 2. Again adding number 2. Now this was my a1. This is a2. This is a3. Let us say the first term, second term, third term. This is the fourth term. So on the first term, I have a1. Second term, I hope you agree that I'm only getting the second term by adding the common difference d to it. So can I write that second term is a1 plus d? All right, I'll have my next number as I'm adding, in order to find a2, in order to find the third term, I'm adding the d twice. 1, 2. So can I write that it is a1 plus 2d? All right, for my fourth term, how many times am I adding d? Let me change the color so it makes more sense to you. 1, 2, 3. So on the fourth term, I'm adding the d 3 times in order to get the fourth term. So when the mathematicians kept on seeing that this pattern continues, at every time the number of the term and the number here is 1 less, they figured that in order to calculate the nth term of a sequence, we can always depend on this formula, where this number will always be less than 1 less than that number. So it will be n minus 1 times d. Everything is the same, but that number is 1 less. So they came up with this formula, and we can always use this formula in order to calculate. All right, with that taken care of, remember to highlight this formula where this d is the common difference. N is the number of the term. A1 is your first term. All right, let's practice a question on the next page. Now remember, we need this formula to find the nth term. We have a1 plus n minus 1 times d. So anytime you have 3 things given to you, you can always find the next one. So we'll do an example question together. And in the question, we have 79, 75, 71, 67, 63. And these are the terms of your sequence. They are telling you to find A 32. That means you are trying to find the 32nd term. And in order to do that, we have, let us identify what we have. So here we have our A1, our first term is 79. Our N is 32. Why 32? Because they are telling us to find the term number 32. And now let us figure out our common difference. Common difference will be, from 79 it came to 75. So that means I'm subtracting 4. Let us check if we are doing that same here also. So it looks like yes, we are subtracting 4 every time. Now let us apply it in the formula. A1, it will be 79 plus what was N? 32. 32 minus 1 times D. D is negative 4. From here is basic solving. 79 plus 32 minus 1 is 31 times negative 4. Now here I've seen sometimes students get confused and they will first add 79 and 31. I would say it's a silly mistake because you know that you have to follow PEMDAS here. So when we follow PEMDAS students, we will multiply 31 and negative 4 first. And I'll have a negative here, 124. So my 32nd term will be negative 45. So students, remember this formula is very useful because any term they can ask you for a sequence. It can be 100th term, 500th term. You don't have to do all the math. You just get the answer by applying it in the formula. And always remember, they'll always give you the other things and there will be that one thing that will be missing and they want you to calculate that one. All right, let's do one last example on the next page. And the example is going to be the same series that they are giving you, given. The series are 79, 75, 71, 67, and 63. They are saying what term number is negative 169. So this time they are giving you, like they're tricking you basically. They are not asking the number, they are asking the number, but they are this time giving you the term actually. So let us identify what we have and what we don't. So by identify means all that information is given to us. A1 is 79 here. N is something we don't know because they're asking what is the term number. AN, this is the term. We don't know what number it is, but it is negative 169. And D is the common difference. And as you can see, I'm subtracting 4 every time to get to the next term. So that's minus 4. And N is what I'm calculating. Remember the formula? Let's write the formula again over here. A1 plus N minus 1 times D. So we will set it up as this is AN. So it will be AN, which is negative 169 equals A1. What is A1? 79 plus N minus 1 times D. What is D? Negative 4. Now students, remember you have to use distributive property here in order to solve it. The problem is we don't know N. So when we don't know N, how we calculate is we do distributive property and combine the like terms. Minus 4n, negative times negative is positive, becomes plus 4. I'll draw a line here so it looks legible. 79 plus 4 is 83. So I combined these two because they did not have an n next to them. Now always remember how we do this concept. N is grumpy. So we will subtract 83 from both the sides. So we can get rid of 83 away. And negative 169, negative 83 is negative 252 equals negative 4n. And what we do next is we divide by negative 4 on both the sides because n is still grumpy. We need to make n happy. And n equals 63. So that means negative 169, as we keep going, is the 63rd term at the end of this sequence here. So any question they ask you about the term can be answered by this given formula. That's why this formula is so important. So I hope it made some sense to you, students. And if there's a mistake, if you find a mistake, do let me know. Like, share, subscribe, and I hope it makes you understood and you learned some math through this. And I'll see you in my next video. Have a good one. Bye.